So now that we know what a capacitor is, in an electric circuit, you may have more than two capacitors, and they may be connected in series or in parallel. Series or parallel connection. For let's just take example three capacitor. For three capacitor that are connected in series, this diagram illustrated three capacitors that are connected in series. C1, C2, C3, which is their capacitance. To get the equivalence of the capacitance of these three resistors connected in series, go ahead to use this formula we have earlier said. Now, what about three capacitors connected in parallel? As this diagram illustrates, if you recall, all positive terminals are connected together. This positive terminal is connected to this, while the negative terminals are connected to each other. This is an example of a parallel connection. How do you go ahead to calculate the capacitance of these three capacitors? It is given by this formula as earlier said. Total of the equivalent capacitance will now be equal to C1 or C2 or C3. Now, let us take an example on this. In this example, we say two capacitors of capacitance 5 microfarad and let's put 4 microfarad. 4 microfarad are connected in series, and the resulting combination is connected across 600 volts. What is that two-part question? The equivalent capacitor of the combination and the total charge on the combination. So let's look at our variables. The capacitance of the first capacitor is given to be 5 microfarad, and the second capacitance of the second capacitor is given to be 4 microfarad. Now, how are these two capacitors connected together? Yes, in series. So to calculate the equivalent capacitance, you go ahead to use what formula? Correct. You go ahead to use this formula. So it will be 1 over C equals to 1 over C1 plus 1 over C2. Because we only have two capacitors, the formula will be modified to this. So because 1 over C equals to 1 over 5 plus 1 over 4. There are many ways to do this. So let's do it this way. We'll take the lowest common factor of 5, which is 20. When you go ahead, say 5 divided 20, 5 divided 20 is 4. 4 times the numerator, which is 4, plus 4 divided 20 to be 5. 5 times 1 is 5, which will result to 9 over 20. You are not looking for 1 over C. You are looking for C. So get C, you just say the reciprocal of both sides. So it becomes C is equals to 20 over 9 microfarads. Now if you don't want to place it in microfarads, you go ahead to times it by 10 raised to power minus 3, which will now give you your answer in farads. Now let's do this part of the box. So to now be C is equals to 20 over 9 times 10 raised to power minus 3. In decimal, 20 divided 9 will be 20 divided 9 will be 2.22 times 10 raised to power minus 3 farads. So we now have the answer in the SI unit. Now another part of the question, what we just calculated for is the equivalent capacitance of these two capacitors arranged in series. The other part of the question says the total charge on the combination. If you look at the question very well, they gave the potential difference across the connection. That is to say, in the other part, 600 volts will not be for what? V. V is 600 volts. And you are looking for what? Charge. Charge is the parameter you are looking for. Already you have already calculated the equivalent capacitance. Earlier on, we said there is a formula connecting these three variables, which was given to be correct. C is equals to Q over V. And because we are looking for Q, Q is equals to CV. Q is equals to, our C here is 2.22 times our volt is 600. Then we multiply it together, 2.22 times 600, which gives us 1302, equivalenting 1332 coulombs. So that is for the two main questions. The first question was to calculate the equivalence of the capacitance of the two capacitors. I move further to calculate the charge, the total charge on the combination. Total charge on the combination. Again on the